Now, it is possible to fully customize your DeFi experience from the swap cycle, meaning before and after the swap, you can add some sort of like logic that allows you to build any other possibilities that it wasn't possible before. From real world assets or even improving the liquidity provider experience that I might be tougher during the weekend for sure. We call that hooks, and these are some of like sort of scripts that you can add now to your liquidity pools. So throughout this call, we are going to, or throughout this talk, we are going to guide you over the Uniswap V4 protocol along with all of the features and a V4 template that after that, it's going to allow you to build and deploy your first hook for sure. Let me introduce you first the Uniswap Foundation. My name is Ocando, and along with my colleague Dayitva, we work at the Uniswap Foundation, and it's basically supports the growth, decentralization, and sustainability of the Uniswap community. And through our grants and other some sort of like incentive and initiatives, we support 5 key pillars from protocol and innovation, developers, we are here for sure, governance, research, and security. So now let's do a little bit of overview around the Uniswap protocol, that it's basically a peer-to-peer system that allows you to swap and like trade a pair to another. Let's say you want to trade ETH for USDC, so you can do that in the Uniswap protocol in a decentralized ways throughout liquidity pools. Basically, a liquidity pool, it is a smart contract that connects liquidity providers on a side and traders on the other. So think about the DeFi projects that you're looking to build. If any swap needed or provider liquidity on it, you can just integrate the protocol. First launched back in like 2018, the Uniswap V1 version. Now we are in the V4 version. Probably you've been interacting with like some of them in the history. It's basically from the V3 version. If we go straight, you can now support ERC20 to ERC20 token. So any token out there, ERC20, you can do it. And then the price curve, it is a concentrated liquidity one, meaning if you are a liquidity provider, you can go over a tick and say, I want to add my liquidity on from 2,000 the price to 3,000 ETH price or whatever. So that's important. And then you used to have some sort of like fixed fees from 0.005% to 1%, but now V4 allows you to define the continuous fee spectrum and dynamic fees, meaning you as a developer define the rules and you can say, hey, I want to define dynamic fees depending on the volatility of the market. So we are in a bull market or a bear one, so you want to adjust all of this information. But also the V4 not just includes that, but rather the singleton architecture. Any of the transactions and everything happens in one contract, all the pools, all the tokens. That's from one side for gas efficiency, but also in the end, you can build a better experience out there for your users. We also had another some sort of like features such as the ERC6909 and also the flash accounting that from internal tokens to arbitrary end connections or operations, it's basically the way that now, as everything is happening in the same contract, you can build a seamless trading experience out there. And as I mentioned at the beginning of the talk, if you remember, I said something like, now you can customize your logic in the swap cycle before and after the swap. We call that hooks, as mentioned, arbitrary logic attached to the life cycle operation. So now everything is focused on gas efficiency, but also developer expression, meaning you guys define the rules for completely. So yeah, this is like a visual example of how it used to work at V3 version of the Uniswap protocol, and now how it's working in the V4 one. So back in the day, if you wanted to trade ETH for DAI, let's say like that, you had to go from ETH to USDC and then USDC to DAI. Right now, everything happens in just one contract, along with the features that we have, as I mentioned, the singleton one and the flash accounting and so on. So yeah, you can see here deploying on mainnet how the price of the gas goes from like almost $60 to $4. And yeah, just a bit of the hooks overview. As I mentioned, this is important because it's basically part of our bounty and like our challenge for you guys during this hackathon, which is build hooks out there, deploying in any chains, but we want you to challenge and build one of these external contracts that basically now modify the pool behavior. Hooks don't just move assets, but define the liquidity behavior out there. Important note in here, only one hook per pool, but then one hook can serve any other pools out there. We have 14 hook functions. Dayitva is going to be at that deal to mentioning that before and after the swap, you can add remove liquidity, or after add remove donations, update fees, and so on. But basically what happens on the swap cycle is that when the swap starts, you can check before, the system checks before swap, and then it's going to validate if you added some sort of logic or not, and return that. If not, just goes over the execution of the swap. And then it's going to check again, but after the swap flag, if you added some sort of like custom logic or node before ending the swap for sure. So at this point, I think we're ready to go over some problem statements for you to visualize better all of the ideas. So Dayitva, go ahead.
So I'll be going over some problem statements that we have designed for you to give you some ideas to hack over this weekend. You're not limited to these problem statements, of course. You're free to use anything else, but this is to give you some inspiration. The first one is the stable efficiency at scale. So the idea here is to design a hook that targets the stablecoin pairs on ETH mainnet with trade sizes over $500,000. The important thing to consider here is, of course, the mainnet gas costs, which can be really expensive. So you need to think about how you design this hook and how does this hook compete with other dexes in this market. One idea that you could possibly do this with is by splitting this trade over time so that you reduce the price impact and not just give them one price execution. The second is the TVAP execution hook. It's closely related to the first one that I just talked about. You need to design a hook that enables TVAP, which is the time-weighted average price. Again, you can split the order into multiple times, and then you can minimize slippage and give a better price execution to the user. Again, you can integrate this with other sponsors like 1inch and the limiter orders, or even with Uniswap's own smart order router. Next is the Pendle-style AMM rebuild. For people who don't know what Pendle is, it has a time-decaying AMM, and it splits an yield-bearing asset into a principal token and a yield token. And it has a really interesting way of pricing these assets, which is not usually possible. But with hooks, now you can enable assets that were previously not possible before. So could you, in fact, design the whole time-decaying AMM by Pendle directly as a V4 hook? Next is the World ID verified pools. So Coinbase already uses Uniswap V4 for its own verified pools. So it offers KYC and AMM institutionalized standard pools to users so that they're not interacting with pools that do not meet the standards. So you can use World ID and build a World ID mini app that only allows verified users to interact with certain pools. Again, this is to improve and reduce disable resistance and improve the UX and the compliance in DeFi. Next is lottery pools with social yield. So Pool Together is a no-loss lottery, which allows you to redistribute the yield redistribute the yield to the stakers. And could you, in fact, design this entire thing as a V4 hook and possibly use this as a hook-enabled world mini app as well? So what you can think is, instead of redistributing the LP yield to the users itself, you store it, and after a certain time period, you give it to one person, or depending on the price pools that you might have. You could also incorporate social rewards, World ID, and gas abstraction features right into this. Next is a smart borrow hook. Another superpower of hooks is the re-hypothecation of liquidity, which means that any liquidity that is not currently active in range, you can just pull that out of the pool and provide it on lending platforms like Aave or Morpho or Compound and give them a better result to the LPs. So you could implement smart borrowing, leverage automation, and even conditional loan logic with these V4 hooks. Next is primary RWA issuance hooks. Again, because hooks enable assets that were previously not possible, you can now have RWAs on V4 as well. So could you design a hook that supports these assets? Also, you need to integrate certain KYC and AML checks. So again, using some of the previous ideas and some ERC 6343 or other institutional standards that you might know of. The next two ideas are a bit complicated, but again, we are looking for open innovation in these cases. You need to design a hook for ETH USDC swap in the less than 5,000 range on L2s. Again, so Uniswap already does a really good job of giving a good price execution for these swaps, but could you think of ideas that take it to the next level? Can you guarantee best price execution and even compete with aggregators with such a hook? The next idea is, of course, to take this a step further, which is the medium-sized trades of 10K to 100K. Could you recapture MEVs for LPs, create an incentive mechanism that boosts volume, or even liquidity depth for such pairs? So these were all the ideas we had. Again, feel free to check out other ideas that we have, and you can build anything literally. Coming over to the resources that we have, the first one is the hook directory. Atrium Academy is the learning arm of UF, and it conducts the Uniswap Hook Incubator, which has a hackathon at the end. The cohort 7 is going to begin almost in October, and the hook directory has all of the projects that have been built previously in these hackathons, along with all of their open source front-end and back-end code. So feel free to check that out for your own inspiration and seeing how hooks have come along. Next is the UF Hacker Toolkit. This is the one-stop shop place that holds everything that you might need, ranging from the ideas that I've just discussed right now, the judging criteria that we have, all of the documentation and the resources that we have as well. So yeah, scan the QR code and get all of that at one place. Next, of course, coming along to the V4 template, which is the bulk of the stock now. This is a template that we have designed for you to get started with V4 hook development as soon as possible. This has all of the dependencies, some scripts to help you out, some test scripts, and a basic hook contract to make sure that you don't have any problems with V4 hook development. I'm going to be giving a small demo of how this works. I've already cloned this repo on my local machine, and the README, of course, mentions the steps to get started with this. This is a Foundry-based repo, so you just need to do forge install, which I've already done, and you can do a forge test to see that everything's worked perfectly. And yes, it does, so it means that the repo has been set up correctly. The main hook contract is in the SRC directory in the counter, and I can just do this. This is a very basic hook contract. You define a hook. A hook contract, again, is basically a smart contract which imports as inherited with the base hook. It has the 14 hook functions that Angela just talked about, which is the before initialize, after initialize, all of the 14 ones with swaps, removing add liquidity, and donations as well. And you need to set them to true, the ones that you're going to be using. In this case, I've set the before swap, after swap, and then before add liquidity and before remove liquidity as 4. So I'm using 4 hook functions in this. And the hook functions are also simple. You just define what the before swap does, and it is a mapping that I'm just incrementing by 1. So anytime a swap takes place, a before swap and after swap should turn into 1. Anytime I add liquidity, this should increment the counter. Anytime I remove the liquidity, this should increment by 1. And this is what the test script actually essentially did as well. So in the test, you can see counter.t.sol. This is a test script that you can use. We set up the entire pool, we add liquidity to that pool, and then we write some test functions. So in this test functions, we check that the before add liquidity was 1, because when we initialize the pool and add liquidity, that should have been called, but all of the rest should have been 0. And after you do the swap, the before swap and after swap should both turn into 1, because in a swap life cycle, both of them are called. Same with the test liquidity hooks. Anytime I remove the liquidity, both before add and after remove should be called. The tests I already showed you how to run. You can do this on a fork of a mainnet, fork of a testnet as well. So I'm going to be using Unichain Sepolia for this. I'm using Anvil, and I've already set my RPC URL, and this should start on a fork of Unichain Sepolia over here. And yes, it's already done. So I can go to another one, and I can just deploy the hook that I've just shown you, the counter.sol. So I would call forge. And deploy hook. What I'm using is a private key from Anvil again. It's a public private key, and again, I'm broadcasting it to the local fork that I have. And the script ran successfully, everything was successful, and we got the hook address over here. We can just take this hook address, go to the base script, and change it over here. Again, the address did not really change because this is all deterministic, and I've already run this before, but these are the 3 things that you might need to change. After you have deployed your hook, you want to deploy a pool and add liquidity to it, but before that, you would want to create some tokens. So I have a custom script called as create tokens. This would just create new tokens for me. 0. This should create two mock tokens for me, and it does. It gives me token 0 address, token 1 address, and it also mints me a certain number of tokens to my particular address. Again, those addresses are already the same, so I don't need to change them, but essentially you would just copy paste over here. After you have created those tokens, now is the time to deploy a pool. So let's deploy a pool now. So this script creates a pool and adds liquidity directly in one script. I can show you what's happening in this case as well. So a pool in V4 is identified by 5 parameters, which is the currency 0, currency 1, fee, which is, of course, can change now instead of the 3 tiers that we had earlier, tick spacing, and of course the hook contract, which is the most important. In this case, you define the pool key, then you set what the starting price should be using the current tick. You specify what the upper tick and lower tick for your own particular liquidity that you're adding should be. You do all of these actions. Again, you don't need to understand this all of lot because it's already in the script, but of course, feel free to come to us if you have any doubts. We do the token approvals, and then we just multi-call with this. And if everything was successful, yes. So a pool was deployed, and the liquidity was added as well. Final step, let's finally do a swap on this. So I can just call the swap script. And I can show you what the swap script is as well. A swap script, again, you define the pool key through the 5 parameters, and you approve both the tokens. You don't need to approve both the tokens. You only need to approve the token that you are going to be inputting in, but this is just for testing. You specify on this swap router, there's a function called as swap exact tokens for tokens. You specify the amount in, the amount out that you want. This is what specifies what the slippage is that you're willing to encounter. I've set it as 0, which is bad practice, but this is again testing. You should, in production, always specify the exact amount out that you are willing to get. Then 0 for 1, which specifies if I'm inputting token 0 for 1 or getting token 1 for token 0. Pool key, hook data, which is the data for the hook. In this case, it's all 0. And the receiver, which is my address with a deadline. And if everything was successful, yes, the swap did take place correctly. And you can just do a swap. So everything is there in this V4 template, right from setting up the pool to doing all of the swap. And yeah, happy developing on this. Yeah, thank you so much.